Yep. All right, so again, chapter 7, section 1 is called linear and nonlinear systems of equations. This means we're going to have systems of equations that have lines, and then we're going to have systems of equations that also have other shapes, like parabolas, that kind of stuff, so you might see x squared. In this section, we're going to cover solving a system using substitution and graphing, and then in 7.2, it goes over elimination. And then we get into systems with 3 variables and 3 equations. So for today and Wednesday, we stay 2 variables. Okay, and we'll eventually cover all the different ways to solve a system. So what is a system of equation? They are 2, wait for it. So plug it in, check to make sure that it equals, the left equals the right, and then it's a yes. If one of those didn't work, it would be no. They both have to work in order for it to be a yes. All right, now we're going to get into finding the solution from a graph. So we're going to graph, and it could be 2 lines. It could be a line and a parabola. It could be a line and a square root. It could be all these different things, okay? We're going to graph the 2 equations, and then where they intersect is a solution to the system. So in this picture, the point of intersection would be here at 4, -1, and that would be a solution to the graph. There are 2 special cases when you're dealing with solutions from a graph. One is if the lines are parallel, or if they are lines. If they're parallel, or if it's like an absolute value and a line where they don't intersect. And for those, it's no solution. So if my graph does not intersect the other one, then it's no solution. If you end up with the same equation, which would mean you're graphing a line on top of the other one, then it's all real numbers. Oh, and I don't remember how WebAssign has that entered. Let me check that. So those special cases are going to happen in all the different types of solving systems. You've got the no solution where it wouldn't overlap. Okay, in your variables, you'll see they'll cancel out and leave you a false statement. And then if it's the same equation, it would be all real numbers. All right, then we're going to solve using substitution. So to solve using substitution, we will solve one of the equations for one of the variables. You get to choose which one. And then whatever that variable equals, you will plug that expression into the second equation in place of that variable. You'll solve for the variable, and then you'll take that first one, plug it back into either of your equations to solve for the remaining variable. And again, there are special cases here. If the variables cancel out, and it's a false statement, like 0 equals 1, okay? Then it's no solution. If the variables cancel out and it's a true statement, like 0 equals 0, then it's all real numbers. If it's no solution, you'll see the instructions and WebAssign actually say to write the word no solution. No spaces, just all one word, no solution. And I'm trying to find if it's all real numbers. I don't know if you have one in your homework tonight. No. All right, so this says solve by the substitution method. So sometimes it's...
Can you go back?
Sure.
I had like the last...
So sometimes it's going to tell you what method to use. Like this case, it says use the substitution method. And then when we get all the way through all the systems, it could just say solve and you get to choose. But for substitution, what I want to do is I want to look at my 2 equations and I want to see what variable is the easiest to get alone. So what's one option here?
Y.
The y in the top, right? So the y in the top doesn't have anything attached to it. It's positive, right? And it's the easiest one to probably solve for. So I'm going to take this first equation and I'm going to solve it for y. So y would equal 9 minus 5x. Then I take what y equals and I plug it into the second equation in place of that y. So I'd get negative x plus 3 times 9 minus 5x equals 11. Distribute the 3, negative x plus 27 minus 15x equals 11. Negative 16x plus 27 equals 11. Subtract the 27. Divide by negative 16. And x is 1. Now I want to take that and plug it back in, and I've got lots of options. I can plug it back into this original equation. I can plug it back into this original equation, or I can plug it back into the one that's solved for y, which is probably the easiest. And I get y is 4. So your answers for this will be written in coordinate point form 1, 4, like that. That's how it will be on your homework. That's how it will be on your quiz, okay, on your test, all of it. That's how you'll write it. On WebAssign, it actually gives you the parentheses, and you just have to type in the coordinate points in between. And pay attention, because if there's more than one, it'll say smaller x value, larger x value, that kind of thing, which you'll see in a second what that would look like. Yeah.
So does it matter which equation you saw at originally?
Nope.
All right.
All right, this one says, solve the system using substitution and then use a graphing utility to verify. So now I've got decimals, you're going to see decimals, you're going to see fractions, yuck, right? But how do I get rid of them?
Multiply.
Multiply, what would I multiply the top one by to get rid of all those decimals? 10. So I need to move my decimal one place to the right, which would be times 10. So 15x plus 8y equals 23. And what do I have to multiply the second one by? Also 10. Yep. So if there was one that was like a 0.32, something like that, I'd have to move it twice. Then I'd multiply by 100. This one, 10, is good for both.
Ms. Supervisor?
Yeah.
So you don't need to multiply by the same number necessarily?
Nope. The whole equation here has to get multiplied by the same number, and the whole equation here has to get multiplied by the same number, but the two equations don't.
How come the 0.1 turns into 10?
It should just be 1.
Be 1.
It should just be 1. Yeah. Thanks for catching that now until I got all the way through. All right, so now I need to solve for a variable. This time it's not as easy, right? There's nothing that's already by itself. I'm going to have to move and divide, so just pick a variable.
X.
In which one? Top one or second one?
The second one. So
Second one? Okay. So we're going to do 3x equals 1 plus 2y, and then divide everything by 3, and I get x equals, I can keep it as 1 plus 2y over 3, or I can make that 1/3 plus 2/3 y. Doesn't matter. Now I'm going to take that, and I'm going to plug it into the other equation, so the first one, in the place of its x. So 15, 1 plus 2y over 3 plus 8y equals 23. 3 goes into 15 5 times, and then I distribute that in. 5 plus 10y plus 8y equals 23. 18y equals, subtract the 5, 18. And y equals 1. Now again, I can take and plug that back into either of the original equations or the one we solved for y, which again is probably, or solved for x, which is probably the easiest. I get x equals 1 plus 2 times 1 over 3. 1 plus 2 over 3, 3 over 3, which is 1. And my answer is 1, 1. And again, I could check it. So if I had extra time, I could come back up here and plug in, especially 1 is easy. Plug in the ones, 1.5 plus 0.8 is 2.3. And plug in the ones here, and 0.3 minus 0.2 is 0.1. So those are easy to check with extra time. Yeah?
Why did you multiply by 15 instead of 3?
I'm using this equation.
Oh, okay.
Yeah, so whichever one you solve for, which is I solved for the bottom one, you have to plug it into the one you didn't solve for. So you have to plug it into the other one. Everybody still good? Yeah, we remember substitution, right? Yes. So on my graphing utility, if I had typed that in, right, and then I hit graph, I would look for where they intersect, and you can trace that line to find the intersection. So every system can be checked by using a graphing utility. All right, then solve by graphing. Oh, this actually. All right, now we're gonna graph. So this says graph each line. It should be line or any kind of, it could be a parabola, it could be square root, whatever. It's just graph. And where the graphs intersect, that's your solution. And we said this already. If they're parallel, they never intersect, then there's no solution. If they overlap or give you the same equation, then it's all real numbers. All right, so it says solve the system by graphing. So the first thing I have to do is identify what types of graphs are these. What are both of those? Lines, parabolas, square roots, what are they?
Line.
They're both lines, right? So I want to solve it for y. So I'm going to take this first one. I'm going to get negative 2y equals negative 3x plus 7. Then divide everything by negative 2. And I get y equals 3 halves x minus 7 halves, or 3 1/2. I'm going to have to graph it, so you're going to want to get into mixed number format. Do the same with the second one. Negative 4y would equal negative 6x plus 9. Divide everything by negative 4. Y equals 3 halves x minus 2 1/4. Then graph. So negative 3 1/2 is my B. So I start there. I'm graphing this one first. And then I go up 1, 2, 3, and to the right 2. I could do it again. 1, 2, 3, and to the right 2. Or I could have gone down 1, 2, 3, and left 2. Whichever works on your graph. So if you have more room to do one the other way, then feel free to do that. And then I'm going to graph the blue one. So negative 2 1/4 is here. Slope 1, 2, 3 over 2. 1, 2, 3 over 2. Or down 2, 3 over 2. What's true about these lines? They're parallel, which means, are they going to ever intersect? No, so this is a no solution, okay? You could have found that from your equation if you looked at the slopes, right? If the slopes are the same, they're parallel. But you will have to graph. So on your quiz, it's going to be like it was on this last one, where I'm going to give you a graph at the beginning. You're going to have to graph whatever it is, whether it's 2 lines or nonlinear, okay? So you are going to have to graph and then find your intersection if there is one. If there's not like this, then it's no solution. Questions on that one? All right, same set of instructions, solve the system graphically. What do we notice about this one?
There's a parabola.
There's a parabola in this one. Good. So I want to graph the first one, still solve for y. So I'd get negative y equals negative x minus 4, multiply or divide everything by negative 1. And I get y equals x plus 4. And then the second one I know is going to be a parabola. So I'm going to subtract the x squared. And then again, multiply everything by negative 1. So it's y equals x squared plus 2. So the first one is a line. I start at 4, 1, 2, 3, 4. Slope is up 1 over 1 or down 1 over 1. Draw my line. Second one's a parabola. What's the transformations on this parabola?
Up 2.
Good, up 2. So I know that point already. I know I'm going to shift it up 2 and I'm going to get here. And then I need exact points from this point, which means I'm going to plug in something to the left of that 0, and I'm plugging something to the right of that 0. So if I plug in x as -1, I get -1 squared plus 2, 1 plus 2, which is 3. That's 1 point of overlap. And then if I plug in the 1 to the right of it, it's also going to go up 1 and out 1. That doesn't intersect. But plug in, let's say 2. 2 squared plus 2, 4 plus 2, which is 6. 2, 1, 2, 3, 4, 5, 6. There's my other point of intersection. These, again, have to be exact. So you're plugging in points to make sure they are exact. So 2, 6 was my other one. So I have two answers here, -1, 3, and 2, 6. If your WebAssign question has two answers, it will tell you I think it says the first one, the smaller x value, so it would be the -1, 3, and then the next one's the larger x value, which would be that 3, 4. You could also solve this using substitution to check. So pay attention to the directions. If it says graph, I'm expecting to see a graph in your homework, and the same would be true for a quiz or test. If it just said solve, you can use any method. Still good?
Ms. Crusoe?
Yeah.
Where's your -1, 3? Which point is that?
That's this one.
Does that go up by 3 or 2? I can't.
It's up. What do you mean up? This, like this line here is 3. This is 2. This is 1.
Oh, I switched to the wrong center.
Oh, okay. Yeah, because we shifted up 2, right? Because of that up 2 shift, this one. That tells me up 2. If you didn't know it, then you would have to plug in 0, and then you'd get the 2. Everybody?
So wouldn't a point of intersection be there as well? The -1, 3?
Yeah, that's this one. So -1, 3, and 2, 6 are both points.
Oh, so we just put one answer, or we have to do
No, you put both.
Okay.
Yeah. And the homework will say smaller x value and larger x value. And then that's how you know which order to put it in. And again, the parentheses are already there. You just have to type the numbers in. All right, so this one says solve the system using substitution and then use the graphing utility to verify your results. So substitution, back to substitution, right? Solve one of these equations for one of the variables. Which one's the easiest one to solve for? The first one, let's solve for what? X. So then x would equal y. I'm going to take that, I'm going to plug it in the place of the x, so I get y to the third minus y equals 0. Then what? Take out a y. Y squared minus 1 equals 0. Good. Difference of 2 squares, got to factor that out. And I get each of these set equal to 0. So y equals 0, y equals -1, and y equals +1. There are 3 answers happening here. So when y is 0, -1, and 1, I have to plug them each in. And again, I could plug it into the top. I could plug it in here. I could plug it in here, or I could plug it in here, which is the easiest because we already solved it for the other variable. So if x equals y and y is 0, then x equals 0. If x equals y and y is -1, then x is -1. And if x equals y and y is 1, then it's 1. So now let's see what this looks like on a graphing utility. I'd have to solve them both for y. So this top one's already solved for y. This bottom one, I would get y, or x to the third equals y. So those are the 2 equations that I'm going to type in. Y equals x, and y equals x to the third. And then I'm going to graph it. So here's what my graphing utility looks like. Okay, it's kind of hard to see them because they're kind of close together. So I can always zoom in on this so I can see a little bit better. Okay, and it looks like they're crossing at -1, at 0, and at 1. If I want exact points, I go second, trace to get my calc menu, and I can go to intersect. And it's gonna say the first curve, where am I at on the first curve? Okay, anywhere on that blue line, yep. Second curve, I'm on the red line, so yes. And where do they intersect? They intersect at 0, 0. If I come all the way over here, oh, I got off my trace. Come down here, first curve, second curve, 0, I'm -1, -1. Hang on just a second, Ty. And then do it again. Intersect, come all the way up to where that third one is. Get closer to that third one than to the 0. And it brings you to the third one at 1, 1. It's way easier to do this on the graphing utility on the iPad. So if you're doing the homework one and you want to use that one, we just tap the screen, okay? It's easier to do. Just keep in mind that you're not gonna be able to do that on a quiz or test because you're gonna be in lockdown. Yes,
I was gonna say before you turn the camera off.
Oh.
Can you show me typed in for the calculator?
Sure. So it should look like that.
All right, thank you.
You're welcome. All right, questions on either of those? Either using substitution or graphing. Okay. Use a graphing utility to approximate all the points of intersection of the graphs of the equations in the system, round to 3 decimal places, and then verify by checking your results in the original system. So I'm going to do this from the graphing utility on the iPad so that you can see what that would look like. So that's what my graph looked like. And again, I double tap the home screen, it pops up and it says find intersection. I clicked find intersection and then I tapped right where they meet. And that coordinate point here is up here in this left corner, which X is 2.25. Both the Y's are 5.5 because that's where they overlap. And that would be my coordinate point. So when it says to verify by checking your results in the original system, it means you can actually plug this in. So if I did the square root of 2.25 and then I added 4 to it, I should get 5.5. So if I type that in the calculator, square root 2.25, it's 1.5 plus 4, and that's my 5.5, so it works there. 2 times 2.25, which is 4.5 plus 1, gives me my 5.5 in this equation, and it works there as well. So if the homework says use a graphing utility to find the intersection, you need to screenshot either the actual graph on your graphing calculator or the one on the iPad, and then include that in your work, okay? So make sure if it says use a graphing utility that you take a picture of it. So this one says you're given the yearly interest earned from a total of $12,000 invested in 2 funds paying the given rates of simple interest. Write and solve a system of equations to find the amount invested at each rate. So first of all, we're talking simple interest now, which doesn't use like PERT, we don't have to use that, or the 1 plus R over N, that's not what we're using. Simple interest is literally like, this is how much is invested, times the percent that you are earning, and that gives you your simple interest, okay? So this gives me that one part, I invest a total of $12,000, so this is the total investment. The annual interest, this is how much money I made after 1 year, and then I've got 2 different rates. So my 2 variables are X, which is the amount of money invested at 3%, and then Y, which is the amount of money invested at 5%. So these types of problems are all pretty similar. They're going to give you 2 different rates, okay? They're going to give you some sort of relationship between them. So I know that the percent of interest times the amount of money is how much money I've made off that, which means 3% times X plus 5% times Y should equal the total interest earned, which is $500. Now I need a system, which means I need one more equation here. And the other thing we know about is how much the total investment was. So that's your X plus Y equals $12,000. So they will always give you some sort of amount about it, about the, the interest rate, then maybe how much money is being earned. And then they'll always give you some relationship. So this type of information could change. Sometimes it'll say the total amount like this one. Sometimes it'll say like you invest twice as much at 3% than you do at 5%. So it would be 2x equals y, that kind of thing. They could say you invest 3,000 more in at 5% than you do 3%, and so that you would set it up that way. This one just gave me the overall total. But now I have a systems of equation. So I'm going to first convert this into decimal. This would be 0.03x plus 0.05y equals 500. And then this is my system. So if I want to get rid of the decimal this time, what do I have to multiply by? 100. And it goes all the way across the equal sign, and that's what people mistakenly forget to do. So this would be 3x plus 5y equals 5,000. Nope, 50,000, because I need two zeros added on. And then the other part of my system is x plus y equals 12,000. Now, right now we have two options to solving systems. We have substitution and graphing. Obviously, I don't want to be graphing something that's like 12, has a y-intercept of 12,000. So I'm going to go with substitution, okay? I'm going to pick the bottom one because those variables don't have anything attached. And then I can say like, oh, let me solve for x. So x equals 12,000 minus y. And then take that and plug it in for the x. So 3 times 12,000 minus y plus 5y equals 50,000. Distribute here. Two y, subtract this here, would equal 14,000. Divide by 2, and y is 7,000. So the first thing we know is that we invested $7,000 at the y was the 5%. Since we invested $12,000 total, how much does that mean we invested at the 3%? What's 12 minus 7? 5,000. So we did $5,000 at the 3%. And an easy, quick way to check that is do 7,000 times 0.05 and 5,000 times 0.03 and see if you add those together, do you get the 500 that you should have made? Okay, these are easy to check.
That's a lot of money.
That is a lot of money. Yeah, that's what happens when you invest a lot of money.
Yeah.
You get back a lot of money.
The more you make, also riskier though.
Very true. Yeah, sure. Any questions on that one? All right, other type of application is called break-even analysis. So to find the sales necessary to break even, you're looking for when R equals C. This is revenue equals cost, okay? And you're doing this for the total cost, C, of producing X units, and the revenue R obtained by selling X units. Round to the nearest whole unit, okay? So first of all, like, what's the point of this? If you're trying to invest something, like let's say you want to sell shirts, okay? And you want to get to the point that you're at least, breaking even means you're not negative, right? Breaking even means it's exactly the same, the break even point. So if I know it's going to cost me, let's say these are very expensive shirts, but let's say that this is this model. It's going to cost me $250,000 to start up my business. So that's this part. The $250 is an upfront cost, right? Then it's going to cost me $8,650 for each unit I produce. So that would be this part. The revenue is how much you're selling those for. So if you're selling, again, these are very expensive t-shirts, but if you're selling your t-shirt for $9,950, that's where the revenue comes from. So this is a systems of equation. They're already set equal to each other. I mean, they're already set up in equation format. The difference this time is that we want to find where the break-even point is, so we just set these two equations equal to each other. So I set this equal to this, 8,650 plus 250,000 equals 9,950x. And then subtract. And then divide. So cancel through the zeros. 2,500 divided by 13. And I get 192.3 units. Now here's the catch with break even. If I asked you to round that number to the nearest whole number, you would tell me it's what?
192.
192. But if you only sell 192 units, you have not broken even. You are still negative. So on break even analysis questions, you always round up. Because if you round down, you have not broken even yet. So you would need to sell 192 units in order to break even here. Hi.
I'm gonna give you rounding up, so where did the answer be
193. 109. Just making sure you're paying attention. 193 units. Okay. Again, if you did 192, you would not have made enough money to break even. Questions on break even. So set them equal to each other, just round up. That's it. And then the last one, you're going to see all sorts of system word problems. Okay, these are like geometry based. So this says the perimeter of a rectangle is 30 meters and the length is 3 meters greater than the width. Find the dimensions of a rectangle using a system of equation. So if you need the visual, do it. Perimeter, 30 meters. Length is 3 meters greater than the width. So if my width is here, then my length is the width plus 3. Find the dimensions of the rectangle using a system of equation. So if that's the case, I want to compare. So I want to set up two different variables. I could solve this with one variable, but because it says find using a system, I want two variables. Okay? So I can make W my width. I can make length my L. And the first thing I know is that their perimeter is 30. So perimeter equals twice the length plus twice the width. 30 equals 2L plus 2W. And the other relationship I have is that the length is 3 meters greater than the width. So L would equal W plus 3. Now I have a systems of equation, which is easily solved using what? Graphing or substitution? Substitution. L is already solved for. So I just take this and I plug it in to the L. So I get 30 equals twice the length plus twice the width. Subtract the 6. Divide by 4. The width is 6. That's one part. And then I plug it back in here. The length is 6 plus 3. So the length is 9. It actually says meters here, so I would know that it is 6 meters by 9 meters if it wanted the dimension. Let me see. Web assign. Oh, I got blocked out. I know if this is a question like on Canvas, on a quiz, you would say what's the length, and you're going to have a space, what's the width, and you'll have a space, and you'll just fill them in. Just trying to see what the format is on Web assign. It says width, same thing. It'll say width and then the space and then length and then a space. So on number 13 on your web assign, you're going to see you actually have to set up your cost function and your revenue function.